Hi, hello everyone. Hi Prasanna. So this is your Ameer sir, Master Teacher of Physics at Vedantu. Now quickly, everyone tell me, how are you all doing? I know that you all are doing super great and had a wonderful day, but if I can hear it from you, it's gonna lit up my mind. Hi VG. So I have a lot many regular students in my classroom. So hi to everyone. So I think you all are doing good, right? Yes, Sukamana Agashe. So we got a Malayali student also in the classroom. So I'm so happy that, okay. So good. Now in Hindi, how do you say that you're super good, right? Sab mast hai, if I'm not wrong. So if anyone is feeling low, don't worry at all, because here we are with the Rapid Sprint 2.0, where we'll be discussing all the chapters for the upcoming JEE, which is going to happen in February, right? Okay, and which session it is? Which session it is going to be? Chernobyl disaster. We are here with the physics, right, Priyanshu? So why don't we discuss physics, okay, and prepare ourselves for the upcoming JEE. Now everyone tell me which session it is of our sprint series. It's the third session, and the chapter which we are going to discuss is capacitors. Very good Venkata. So welcome back, happy to see you again. Now everyone, whoever is new to the classroom, give me a yo or give me a thumbs up in the chat box, so I can understand how many new students are there, so that I can give you a brief about the Rapid Sprint series. So the Rapid Sprint series is nothing but, okay, me and Garang sir started so that we'll be going through all the objective questions from all the chapters before we start with our JEE main, which is going to happen in Feb. So you can see the calendar here, right? So today is Jan 15th. We are doing with capacitors. I have completed electric field and potential. Those who are not there, it is still in YouTube. You can go and watch the video and learn a lot much of things. Right? Okay, so we have Priyanshu and Akash new here, right? So I was talking, and you can find out the schedule for the upcoming classes. Take a screenshot and be there in the classroom all the time. Thank you so much, Venkata. Thank you so much. Now, if you don't want to miss any of the classes, okay, which is going to happen from a sprint series, don't forget to subscribe now itself. Move your cursor, click on the subscribe button, so that you will get the notification whenever a new video is up. Okay, so don't miss your chance now itself. Don't be lazy. Now itself, everyone, move your cursor to the subscribe, press it. That's all you have to do. So hello Vijay. So one more thing, whatever questions here we discuss, it will be uploaded in the Telegram group also. I hope you can see the link, okay, and you can click on the link and yes, be a part of the chat box. And one more thing, now here the Vedantu have started with the fast track courses, okay. So the crash course, we'll be discussing the entire topics along with the theory. In 5 weeks we'll be completing with a lot much of mock tests, everything. You'll be given the personal care, and we'll make sure that you are going to be in where you are going to be in the colleges whichever you are dreaming about, right? Okay, so you can come and be a part of it, and don't forget to apply the code which is AMECC, because you don't have to pay 10,000. Once you apply the code, you'll be getting it for just 8,000 rupees. Yes, it is like one shot only. We are live, right, Afra? Okay, so shall we start with the very first question? Are you all ready for that? You already subscribed, so just everyone be like Agash, okay, and everyone do the subscription now itself and make this session super amazing. Are you all ready for the very first question that you can see right on the screen? Are you all ready for that? If you give me a yes, then here we go. Here we go. So, okay, Akash, this is not the time to discuss that. We'll discuss about capacitors. So I'm going to start, okay, thinking that everyone is super excited for the class. Now we have 3 capacitors, right? Each is having a capacitance of 2 microfarad, as you can see that, are connected with a battery of EMF 30 volt. Everything is there in the figure. When the switch S is closed, the amount of charge flown through the battery. So first we have to understand what is the amount of charge that is flowing through this particular circuit before the switch S is closed, which means while it is open, we have to find out. What is the simple formula to find out the charge in a capacitor circuit? What is it? Shall we start writing? So yes. 1 minute. 1 minute, you have to give me some time. So okay, 1 minute, let me start writing. So okay, why is it not coming? Yes, it's here. So I'm really sorry for that. Yes, so what has to be done here? Now we know that the total charge Q is equal to, okay, what's the formula? Q is equal to C into V, right? Okay, we know that Q by C is equal to potential, so Q is equal to the effective value for capacitance into potential, right? Okay, now here we go. What is the effective value for capacitance? First we should be knowing that how to find out the effective value of capacitance, isn't it? Yes. So let's start from here. So first, these two capacitors, as you can say, let me mark it as 1 and 2, are connected in what fashion? Yes, in the parallel fashion. What is the equivalent value for capacitance? It is just opposite to that of resistors. If you connect two capacitors in parallel, the total capacitance is equal to C1 plus C2. So for these two, let me write the C equivalent is going to be C1 plus C2, that is 2 plus 2, because it is given that each is having a capacitance of 2 microfarad. So 2 plus 2 is equal to how much? 4 we have. Simple, right? So this total is having a capacitance of 4 microfarad, and this third is connected in what fashion? In the series. And in series, the equivalent value for capacitance is calculated as 1 by C is equal to 1 by C1 plus 1 by C2. So here you have 4 microfarad. Yes, so that is equal to 1 by 4 plus, and the second one is having 2 microfarad, that is equal to 1 by 2. How can you do it? Let me multiply it with 2 so that a common denominator will be there. So here we have 3 by 4, right? That is 1 by C is equal to 3 by 4, or C will be equal to 4 by 3. Right? So here we have the capacitance as 4 by 3, how much? In the unit of microfarad. Right? Isn't it simple? Yes. So now we can actually substitute it here. So the value for charge Q is equal to 4 by 3 into 10 power minus 6, because it is in microfarad, into the potential is equal to 30 volt. So 30 by 3, it's 10. Right? So 10 into 4, it's 40 into 10 power minus 6 coulomb, or 40 microcoulomb was the initial charge. Okay, before the switch S was closed, this was the charge that is flowing in the circuit, that is equal to 40. That is not the question, okay, because we don't have the answer yet. The question is, once we close the switch S, how much more charge is flowing through the battery? That's the question, which means after the switches S is closed, we have to find out how much charge is flowing through the circuit at that point of time, right? So let me close the switch. Fine. Once the switch is closed, as you can see that here the charge goes like this, charge goes like this. Now the circuit is being short circuited, which means it will remove these two capacitors, and the charge will only be passing through the third capacitor here, because once we close the switch, we are actually short circuiting the part. So we only have one capacitor where we are applying a potential of 30. So the value for charge Q is equal to C into V. The only capacitor is the third, with a value for 2 into 10 power minus 6 farad. 2 microfarad means 2 into 10 power minus 6 farad into potential is equal to how much we have? Yes, it's 30. So this is equal to 60 microcoulomb is the charge dash. So initial charge was 40, now it became 60. So how much charges more has to flow for the conversion from 40 to 60? Who is going to tell me that? Who is going to tell me that? It is the option D here, which is 20 microcoulomb. Right? Simple, isn't it? Vijay, don't worry at all. We are going to start, because now what we are thinking is, let us focus mostly on the February JEE mains, right? Let's see, is there any slot so that we can start with the theory classes. Now here, because I'm explaining the theory also, I hope you are understanding each and every part, whatever it is being discussed, right? So Prasanna, all good, fine. Shall we move to the next question, if you all are ready? Okay. Now let's move on to the very next question. Where is our next question? Yes, here we have the next question, right? Ready, steady, go. A parallel plate capacitor with air as the medium between the plate has a capacitance of 10 microfarad. Now, let us first substitute that and represent that. That will be better, right? So here we can see a parallel plate capacitor with air, right, as the medium is having a capacitance. If it is having an area of A, right, and the distance between the plate is D, what will be the value for capacitance? That is A epsilon 0 by D. Nobody is having any issues with that, I suppose, right? Okay, now moving on. The area of the capacitor is divided into two equal halves, right, and filled with two medium as shown in the figure, having dielectric constant K1 and K2. Okay, the respective values of K are given. The capacitance of the system will now be. Okay, so how it can be done, or what is actually said in the question? Initially it was an area A. What you're doing is, now we are removing the air medium, we are keeping it with some dielectric. So here the dielectric constant is equal to how much it is? It is given as 2. The area is only A by 2. Here the rest A by 2 is filled with a dielectric constant of how much? It is 4. How to find out the equivalent value for capacitance of the system? It's very simple. Now you can actually see that across this potential difference, this is the above one is one capacitor and the below one is the second capacitor, which is connected in parallel. Yes or no? You can consider this as the capacitance C1, this as the capacitor C2. It is connected across the same potential, which means this capacitance C1 and C2 are in parallel. So the equivalent value for capacitance is equal to C1 plus C2. Okay, how will I get the value for capacitance C1? That's equal to K1 times A epsilon 0 by D. So that's equal to K1 times, area is not A, it's A by 2 only. It occupies an area of A by 2, right? Into epsilon 0 divided by D plus the capacitance for the second part, which means this, that's equal to K2 A epsilon 0, A by 2 it is there, by D. Right? Isn't it simple? Now what we can do is, taking A epsilon 0 by D by 2D as common, right, inside the bracket we have K1 plus K2. This is the equivalent value for capacitance, right? Okay, moving on. Now A epsilon 0 by D, which is A epsilon 0 by D was C, which is given with the value for 10 microfarad. Right? This was initially given as 10. So A epsilon 0 by D, from here I am going to substitute it as 10. What we have an extra 2, and K1 and K2 values are 2 plus 4, that is 6. For 6 by 2 it is equal to 3 into 10, that is 30 with the unit of microfarad. Okay, Vijay and Prasanna, I think I am explaining all the theory related to this. And the derivation, I think this is not the right time for derivation, because we are not preparing for board exam here. We are actually preparing for our upcoming JEE. So mainly we should be knowing about all the formulas and where the formulas has to be applied, what all concepts are in it. These are the things for the time being we should be knowing. And I hope it is totally clear to everyone here. Yes? Is it a yes? Okay, please be active in the chat box. Okay, do let me know that you all are super excited about what is going on here. Everyone is noting down the problems, I suppose, and everyone is smiling because you are understanding the concepts. Okay, so if that's happening, that is awesome. So let's proceed with the next question here, right? Okay, so what do we have? Yes, 30 we got it. Next, shall we read? Okay, now Tornado, hi. A parallel plate capacitor of plate separation 2 mm is connected in an electric circuit having a source voltage 400 volt. Okay, Yes. If the plate area is equal to 60 centimeter square, not a cube, okay? So let's so this was just a square here. Then the value for displacement current, right, for time period of 10 power minus 6 second will be. You all know what a displacement current is. The current that is produced in between the capacitor plates during the time of charging whenever the electric field between them changes is simply what we call it as a displacement current. More about displacement current, I think it is there in the electromagnetic waves chapter. Right? Question is to find out the value for what? The displacement current, right? What is the formula for displacement current? ID is given with the formula of epsilon 0 into d by dt of electric flux, okay, phi E. Now again making the substitution, that is d by dt of the electric flux is given by the formula of E into area. Right? Again, epsilon 0, area is a constant, it comes outside, right? E, electric field, can be written as V divided by D from the chapter electrostatics. No issues, I suppose, right? Electric field is equal to the potential difference divided by the distance across which the potential difference is being given. Simple, right? So that is equal to A epsilon 0 E by D, okay, by time. Fine. Okay, now let's start substituting the values of each and every one. That is equal to 8.85 into 10 power minus 12. Area is equal to 60 centimeter square, or 60 into 10 power minus 4. Why 10 power minus 4? Because we have to convert from centimeter to meter square, right? Again, what do we have? A potential, it is given as 400. Then what is there? Epsilon 0 A V by time is equal to 10 power minus 6. Yes, 10 power minus 6. And the distance is how much? 2 millimeter. Oh my god, lot many values to be written. You also have to do this. There is no other things to be done, because here we have to get the answer, isn't it? Yes, all good till here. Any issues, you can speak up and ask me now itself if you have any issues or any doubts, anything. No, I suppose, right? So moving on. So now we are left with the calculation. So how much will we be getting? The answer is equal to, what's the question? Yes, it's gonna be almost 1.6 into 10 power minus 2 amp. So here we are in the answer page, right? Actually, is it totally fine to everyone? Is it clear? Is it super clear? No? Yes? I hope no one is sleeping out there. Everyone is so much active and waiting for the next question. If you don't have any doubts in this, shall we move on to the next? Yes, no, yes, no. What is it? I think it's a yes. So yes, we are moving on to the next question. Okay, so here we have, let's discuss it. Let's start reading the question together. Here we go. 3 capacitor of capacitance 4, 6 and 12 microfarad, right, are connected first in series, then in parallel. What is the ratio of equivalent capacitance in two cases? This is very simple. What are you supposed to do? Just find out the value for capacitance once they are connected in series, then find out the value for equivalent capacitance once they are connected in parallel. Take the ratio. Answer is in your hand. Let's start. So initially they are connected in series. We have 1 minute. Right, so initially we have the capacitor 1, 2 and 3, right? 1, 2 and 3, that's equal to 4, 6 and 12, which is connected in a series. So the equivalent capacitance formula is 1 by C equivalent is equal to 1 by C1, 1 by C2 and 1 by C3. Yes, so this is given as 1 by 4 plus 1 by 6 plus 1 by 12. Yes or a no? Yes. Now I think it is better to add this up with a common denominator. So how can you do it? Multiplying it with 3, 3. This is with 2 and 2. So how much it became? 3 plus 2, 6, 7. right? Isn't it 7? 3 plus 2, 5 plus 1, that is 6. I'm sorry. So 6 divided by 12 is 1 by C, or C is equal to 12 by 6, that's equal to 2 with the unit of microfarad, because all are in the units of microfarad. C is the answer. I think so. Let's check. Okay, be with me and let's see what's the answer going to be. Tornado, right? Okay, so everyone be like Tornado, be active and give your answers. I'll be so happy to see that. Moving on to the next part. Once they are connected in okay, once they are connected in parallel like this, okay, we have 4, 6 and 12. So in parallel, the equivalent value of capacitance is C1 plus C2 plus C3. You have to know that, okay? It is just the opposite of what happens with resistance, that's all, right? So we have a C1 plus a C2 plus a C3, that's equal to 4 plus 6 plus 12, right? So that's equal to 6 plus 4, 10 plus 12. So that's going to be 22 with the unit of microfarad. So here we have C equivalent in series, C equivalent in parallel, ratio of equivalent capacitance, that is equal to ratio equal to C of series divided by C of parallel. What is C of series? I think it was 2. C of parallel, it is 22, right? So that is equal to 1 divided by 11. So small here and there change is there. It's not option which says C, it's option B, right? As you can see, right? Can you see that? No, yes sir. So that's why I told you, whatever you learn in resistor, here it comes just the opposite part. Got it? Okay, so I hope you all enjoyed the session till this part, right? Without having any doubt, I hope everything is clear. So we have Tornado here with us, super active student in the classroom. So I'm so happy, Tornado. So I hope you are gonna meet me for the next class also in the first which means in the first time I have actually shared the schedule, so you can go back, and which means you can actually watch a replay and see the schedule, and let's see, which means the next topic is going to be what? The next topic is going to be none other than our current electricity. Now I know that you all love the classes, right? Didn't you all love the classes? Because we did a lot many problems, we learned a lot many concepts. Obviously you should be loving. So don't hesitate, move your cursor now itself and hit the like button, right? And if you think that your friends are gonna get benefited, do press on the share, right? And I think you don't want to miss any of the classes which is happening from this 2.0 super sprint, right? So please click on the subscribe button, because once you click it, you will get the notifications whenever the classes are going to happen. And for all these things, we just need a small compliments from you, and you can do the compliments, right? You can actually appreciate us just by clicking on this the subscribe button. So we all will be enjoying it. So thank you so much for what you did here, right? Okay, so bye everyone, till we meet next time, take care and enjoy the rest of your day.